decided that we wanted to start the Baja team to give undergraduate engineering students the design, manufacturing, and testing experience that you get in Formula SAE, so they can have that experience and do better in the FSAE program, as well as apply what they're learning in classes to an actual project.
If you look at all the competition, it's all very homogeneous. Our new design and our new strategy, we're able to break into a market and really create our own segment, which is something that will benefit us in our business case.
Being on this team has helped me become a better engineer because I've seen firsthand how designs get implemented and problems that can happen when you're working on the car. You know, you see a lot more complications that you wouldn't have seen just looking at a computer.
In building it, you actually start to learn which parameters of design are good to focus on. And at the end of the day, that's the only thing that actually matters, is how our car performs in real life, not how it performs in a simulation, not how it performs in looking good on a computer screen.
All right, Yuval Duran. Did I say it right?
Yes, ma'am.
Yuval Duran.
Or just UV.
UV, even better, so much easier.
Even easier.
Thank you. He is the advisor for the Formula SAE team. The video that you just saw, they just came back from winning their second straight national championship.
Yes, ma'am. So this is a collegiate sort of a practice, or not a practice, but a program where over 100 universities get together every year and compete. And the idea was formulated in 1983, actually as a professor from UT that started the program. And the idea is to get engineers hands-on engineering practice, so they can, not just theory, but let's do something and get them together and compete. And that's how it started. And it's since manifested into this worldwide organization. Teams do come from around the world, and it's very exciting. And yes, we were fortunate enough for second year in a row to win this.
That's terrific. It was so fascinating to hear one of the students say, it's good for them to be able to do this and to get that hands-on, as opposed to, in theory, this is maybe how it would work, but then they think that's how it's going to work, and then they actually apply it. And I would imagine sometimes find out that it works a little differently.
Yes, so in our engineering programs today, we do focus a lot on the theory, and we do attempt to provide the students with an ability to practice what they learn. This program facilitates that in a very meaningful way. It's very in-depth, it's a very short program, and provides the students with real engineering practice in a means that they would not have otherwise.
I think I was reading somewhere, correct me if I'm wrong, that some of the teams that compete just continue to improve the same car each and every year, but your team starts from scratch every year?
So it's interesting. The industry of the collegiate series has morphed. Like I said earlier, it had started with the idea to provide students with engineering practice, but the word on the street, it's called the racing virus, which the program has morphed itself into racing teams, where many of the schools will simply, like you just said, they will not regenerate, but reuse older designs. They will simply modify slightly and don't give the engineers the full opportunity of doing things from scratch. In our program, and we're lucky that our department head, Dr. Polycarpou, allows us to do this, but the ability for us to be virgin-like with our design approach, the students have to justify everything they do from scratch.
Wow.
We form brand new teams every year, and this is not like a research project where you built on previous literature or previous experiment. They have to do this from scratch every year. This provides them with all the design reasoning. Why do I do this? How do I do this? Where do I go wrong? And does set our program apart from everybody else in a very big way.
Well, and the fact that, I'm assuming, what, about 9 months to build?
So yes, it's less than that. In actuality, we get together in September. It is part of our capstone engineering, it's part of the curriculum. So we get the team together in September. They have 2.5 to 3 months to design this car from scratch. And mind you, when I say design, it's not just putting things together. They go through a very rigorous, iterative design approach between the teams, between members of the team, and until they finalize this. Then they have about 3 months to fabricate this car from scratch. And they make all their own parts. Like nothing is purchased out, nothing is contracted out.
Oh my goodness.
And they don't know how to do this, so they have to learn as they go along. and that's why the program facilitates so much. So in 6 months, they're actually done. Then in about 2-3 months, they had to practice. We go on the track, we practice with our drivers, because that is part still of the project. It's not just building, it's now let's build it and let's utilize it.
That's fantastic. So when they are at these competitions, I would imagine the excitement's got to be just a little high.
So I used to have a black beard before competition, and in the last 2 years it has turned white, and I think it's due to it's very, very stressful. It's not just a competition in terms of racing the car around. The competition is made out of an event, so there's a static event where you get judged on how you designed. That's number one. And then did you pass all the technical requirements? Because they actually use true race car rules in order to practice this. So there are rules and standards that they have to comply with, and the car gets tested for that. Then the students actually get checked on how did you design. Then we get to actually race the car, and then the car has to perform and not die. So it gives you a correlation here is out of 50 cars that were able to actually participate in the final effort, only 14 finished the final effort, and we were number 1.
That is phenomenal. Engineering.tamu.edu. I keep giving you that website because it's so fantastic. So much going on at the College of Engineering, and this is just one of those amazing things they're doing. Thank you so much for being here, Yuvi. I appreciate it. It was good to meet you.
Yes, ma'am.
All right.
All the best. So long.
And to you too. We'll be right back.